Hey all, we're studying permutations. Why didn't the Romans find algebra challenging? Duh, because x equals 10. Roman numeral x is the value 10. Here we go. How many ways can Tara rearrange the letters in the word staple, S-T-A-P-L-E? There are 6 letters. Number 2, Joni has an Algebra 2 and US History textbook. Dan has an Algebra 2 and Biology textbook. They share a locker. How many arrangements are possible for their textbooks in their locker? That one's going to be a little bit more interesting. You can pause, try those out. The answer is going to be on the next slide. 6 factorial ways to rearrange the word staple or letters in the word staple, thus giving you 720 possible arrangements. The one for Joni and Dan, well, given 4 textbooks, we're going to take 4 factorial, and we have to then divide by the 2 factorial because of the 2 Algebra 2 textbooks. Here we're going to say in a locker the books stand up and down, so we can't see the number, therefore giving us some identical objects. When we talk about permutations in this class, especially in this probability unit, first of all, we're talking about arrangements of objects, not a probability. Secondly, we have to keep in mind that there's going to be a specific order. And third, objects can only be used once. When we're talking about objects that can only be used once, we're talking about people, letters, numbers, anything that we're trying to arrange. Most commonly, we're going to be working with the linear permutations, because in linear permutations, we're talking about arrangements in a straight line. At this point in time, if you have been in class, should be familiar with factorial. The symbol here was with the exclamation mark. When we have 6 factorial, we have 6 times 5 times 4 times 3 times 2 times 1, as you recall from the warm-up. When we're taking just the number of objects and we need to use all of them and we're arranging them in a line, there's n factorial ways, like 9 textbooks on a shelf, a batting lineup, stuffed animals. All of these things, when you're arranging things in a line, there's always going to be n factorial, where n represents the total number of objects. Now, when we focus on only using part of all of the objects, meaning we have a total number of objects, n, and we only need r of them. Here in the example, there are 7 students who could be selected as president, vice president, and secretary. How many ways could 3 students be elected in those positions? Well, we're given the opportunity to deal with 7 total students, and we need to select 3 of them. In class, we dealt with decision charts, where you've done 7 people we can select from to be president. Once that person is selected, there's only 6 left over to select from, and then 5. The formula allows us to take 7 factorial and divide that by 4 factorial. Because again, those are the number of students that we are not using. We've dealt with this with Mississippi and the stuffed animals in the warm-ups the other day. How many ways can you rearrange the letters in the word below Hawaii? There are 6 letters, so 6 factorial ways. 2 factorial for the A's, because those repeat. And again, 2 factorial for the I's. thus giving us 180 ways to rearrange the letters in the word Hawaii. In class, we've dealt with Mississippi. For your practice, go ahead and try spell. How many ways can we arrange the letters S-P-E-L-L? Again, there are 5 factorial ways to arrange the letters in general. Then we're going to divide out by 2 factorial for the 2 letters. Because S-P-E-L-L, even though it doesn't look different, someone may say that's different because the 2 L's switch. So we need to divide out again by all the arrangements that would be exactly the same when you switch out the L's, when they just switch spots. Circular permutations, one that we're not really going to deal a lot with. We're going to just discuss it a little bit more in this unit here in this lesson, but we're not going to spend a lot of time on it. 5 people sat around a circular table. How many arrangements are possible? And again, still represents the same things and represents the total number of objects. In this example, we have 5 people, hence 5 factorial. And then we have to divide out by 5. Now the reason we divide out by that 5 right here is because of the rotations that will be the same. Circular rotations or circular permutations have no beginning nor end. So the arrangement that you're going to see here is the same arrangement. These are the same arrangements. We just rotated each person over 1 seat. Well, in this example, there's going to be 5 exactly the same arrangements because there are 5 seats that everyone can rotate into, thus giving us 24 possible arrangements. As you're preparing for your unit test coming up, keep in mind that permutations are a few things, right? If we go back to slide number 1, just see if you can go back to those linear permutations and keep in mind that we are talking about specific order and arrangements.